in which 67% of the global agricultural productivity is accounted by Malaysian farmers. From this we can conclude that the region is food self-sufficient. There were four resources of information about the sensitivity of farmers to climate. The first one is the agronomists have conducted controlled experiments in greenhouse houses with different temperatures. The second is the agronomic crops simulation model key grains such as maize, wheat, soybean and rice. Then the cross-sectional studies of specific crop yields at different climates and estimation of cross-sectional economic models using land values and farmland revenues across climate zones. From these studies, it was concluded that the crops are sensitive to changes in temperature, and the consistency of these findings suggested that there is a high confidence that crops are potentially vulnerable to climate change. Although there have been numerous studies in Asia, the results are scattered. There is a methodology. The results and discussion. The methodology was based on Ricardian studies of crop, and from that it was noticed that concluded that the results were the next study. The next study explains the variation of observed net revenues per hectare of cropland across climate zones across China. This table shows that the spring temperatures have a K-shaped relationship with net revenues with a maximum at 6 degrees Celsius, and summer and winter temperatures have U-shaped relationship with net revenues with a maximum at 19 and 10 degrees Celsius. Depending on the temperature of these seasons, the marginal could be either negative if cold and positive if hot. The overall effects of uniform warming across 4 seasons in China is negative as the negative spring and autumn effects dominate the positive effects in winter and summer. The overall migration effects of a uniform warming at the average Asian country is also negative, again because of the dominant negative effects of spring and autumn. In this paper we examine two uniform warming scenarios: an increase of 1.5 degrees Celsius and an increase of 3 degrees Celsius above the 1960 to 1990 climate normals for each country. From the second table 2, we conclude that the only two is the table 2 reveals that the warming of 1.5 degrees Celsius with no other change in prediction to reduce annual net revenue across the entire sample of countries by $92.6 billion, a reduction of 13%. And the effects are not uniform across all Asian countries, but most countries are predicted to lose crop.
So you have to explain, see, when you explain the table 1 I will understand what you need the equation to understand this. I don't know much about that table 1. Guardian model I am not studying. Just to understand what is Guardian model, that paper was given. So now we know that what parameters are used. So better to go to table 2, which we can easily understand. In table 2 you have to first see the title of the table, what it is aimed at, and you have to also tell us whether the minus sign indicates negative impact and there is no positive or plus sign. So all other are positive impacts. In revenue, crop revenue in Indian US dollars per year, which is gained or lost in the. So that is how you explain. For example, we ask you what is the unit of impact?